Now let us discuss the concept of principle of superposition. Before going to this concept, first let me explain the concept of source. We know that, see, if I take this as a light source S1, when I switch on light, what will happen? It creates disturbance. That disturbance will travel in the medium in the form of waves like this. Okay. Now I'll assume one more source S2. Again, when I switch on this source S2, it creates disturbance, and this disturbance travel in the form of waves. Okay. Now let me concentrate on this source S1. So now my point of observation is this point. Now my point of observation is this point. Now when I switch on only this source, then what happens? Disturbance will travel in this direction, and this disturbance will travel in the form of wave. And what happens? This wave on this particle, it creates some displacement. Let me take that displacement as y1. Now, okay, now I'll switch off this source S1 and switch on this source S2. Then what happens? We know that from source, light will travel in all directions. Now I'll consider the wave which is traveling towards my point of observation. That is, that wave will travel like this. Okay, when it reaches my point of observation, this wave will create some displacement on this particle. Okay, let it be y2. So now the concept is, when only this wave passes through this particle, this wave created a displacement y1 on this particle. Similarly, when this wave travels like this wave created a displacement y2 on this particle. Now the question is, when I switch on these two sources at simultaneously, what will happen? Two waves will travel. Okay, this wave will travel like this wave will travel like this. Now the question is, what will be the displacement of my considered particle? Okay, the displacement of my considered particle will not be y1 or y2, but some other value y, whose value is given by the concept of principle of superposition. Now let us go to the statement of principle of superposition. When two or more waves are simultaneously superposed on a particle of a medium. So this is my particle of the medium. Now on this particle, what is happening? Here it is given that two or more waves, but I'll consider only two waves. On this particle, what is happening? Two waves are superimposed. Then the resultant displacement, that is y, of any particle is equal to the vector sum of displacements produced by each of the waves. That is, y is equal to y1 plus y2. This y1 plus y2 is nothing but the vector sum. So now the resultant displacement of this particle, when I switch on these two sources, will be equal to the vector sum of y1 and y2. So this is the concept of principle of superposition. Next thing is, now as I said that the resultant displacement y is equal to the vector sum of displacements of two waves, that is two individual waves, or when these two waves reach that point. Okay, now what will be this displacement? This displacement may be displacement of the water in the case of water waves. Okay, now if I assume water waves, then it will be the displacement of the particles. That is, as we know that when wave travels like this in water, the particles of water will move up and down. Okay, so that is this displacement. Now if I take a light wave, that's what I wrote here. Means this is the case where I consider two light waves. Okay, so if I consider a light wave, then what happens? y1 and y2 are the magnitudes of electric and magnetic field in the case of E.M waves. Okay, now what is this E.M waves? We know that light waves travel in the form of electromagnetic waves. Now these electromagnetic waves consist of electric field vector and magnetic field vector. Okay, now in this case, y1 and y2 will be the magnitudes of electric and magnetic field vectors. Okay, so in the case of water waves, y1 and y2 are the magnitudes of displacements of the particles. But in the case of light waves, which are E.M waves, y1 and y2 will be the magnitudes of electric and magnetic field vectors. Okay,